Hello everyone, you are welcome to this channel. Today we shall be looking at a further example on how to obtain reaction parameters from the batch reactor data. In the last example, we tried to evaluate the specific reaction constant from the batch data. Today we shall be evaluating more parameters like reaction order as well as specific reaction constant in this example. So let's look at this. The reaction of triphenyl methylchloride and methanol was carried out isothermally in the batch system. This is the triphenyl, this is the methanol to form this and this. And uh, the concentration time data was given like this. So concentration of the triphenyl, the reactant, with time. This is how it is changing, it's reducing with time. Please, let's look at this. You will see that this 50 has been multiplied by 1000 before you get this. So that means the actual value was actually 50 divided by 1000, which is 0.05 mole per dmq. So that was the initial. So this one will be 0.038 mole per dmq. So that's how it is reducing with time. Then the second reactant, which is the methanol, it was initially at 0.5. So one thing you will notice that this one, the triphenyl is at 0.05 initially, and the methanol was at 0.5, which means the methanol was far larger than the triphenyl at the initial stage. So the questions are: determine the reaction order with respect to triphenyl, and 2, in a separate experiment, the reaction order with respect to methanol was found to be first order. Determine the specific rate constant. Simply, the reaction looks like this: A plus B to C plus D. So the first point is to determine the reaction order with respect to triphenyl, and the second one is to determine the specific rate constant for all of them. So now, you remember the 5 steps of reactor design. The first one is mole balance. The second one is what? The rate law, determine the rate law. The third one is what? Stoichiometry. The next one is what? Combine. And the last one is what? Evaluate. So 1, 2, 3, 4, 5. Those are the 5 steps you need to pay attention to. So now, the mole balance. The reaction is in batch system. So it's in batch system. Therefore, we need to use the batch reactor design equation 1 over V dNA dt equals to RA. Then the rate law. Now, in this case, unlike the last one when only one reactant is active, the other one, which is water, was not active. But in this case, the two are active. That's why they say, in the second question, they said B is first order. So, but for A, we don't know. So that means when we write the rate of reaction, we write it for the two of the reactant. And we don't know the order. This is alpha, this is beta. Even though they give us this beta as 1, we are going to use it later. So there are many unknowns now. We don't know Ka, we don't know alpha, we don't know beta. So 3 unknowns and 1 reaction. So it's difficult to solve. So we try to simplify this to make our life easy. So now we were told that CB doesn't change much because it is very large than that of CA. So CB is like the original CB naught. It doesn't change much. Now, what we can do from here is to try to compress this. RA is equal to Ka CB naught beta and Ca alpha. So let's try to represent something with all of this. So we put that as K prime. So that means our RA is equal to K prime Ca alpha. Fine, we have compressed it. So that means we are only looking for alpha as well as K now. We are looking for, oh sorry please, this is minus RA is equal to Kc. So now, stoichiometry. Stoichiometry is simply saying that we should find measurable quantity in terms of the, so we are given mole now. mole is not easily measurable, but we know concentration is easily measurable. So we can find Ca is equal to Na over V. So that means if we put this V here under Na, we can put it as Ca. So that means we put Na over V will become our C. So now let's combine now. So what we combine is to do what? We substitute for that 1 over V, the Na dt becomes what? So that is the Na over V. This one is equal to the Ca. So let's put that into this equation 1. Let's put everything into equation 1 to combine. So that means what? The Ca dt is equal to Ra. And what is our Ra? Minus K prime Ca minus K prime Ca alpha. Good. So we don't want to evaluate now. To evaluate, which is the 5th step, is now the issue. The problem is that we have the Ca dt equals to K prime Ca alpha. Unlike in the last example we did, it is easy to put Ca under alpha. That is, we can have something like the Ca over Ca alpha. But the problem is that it's difficult, it's not easily integratable. We cannot integrate it because we don't know alpha. Is it 2, is it 3, is it 4? So it's difficult. So we have to use another method. That's why we cannot collect like terms, unlike what we did in the last example. So we have to take natural log of the two sides, take natural log of both sides. So it means ln, sorry, there's minus here. We can put the minus here, ln minus dCA dt is equal to ln K prime plus alpha ln Ca. Good. So we need to find, if we plot this against this, the slope will be alpha, and our what is it called? The intercept will be ln K prime. So we plot ln dCA minus ln Ca. I mean against ln Ca, we are going to get the slope of alpha, and we are going to get the intercept of ln K prime. So how do we now get how do we get dCA dt? That is the issue. There are many methods to get that done. We can use graphical method. We can use differentiation method. We can use integration method. We can use polynomial to get that done. I would prefer this polynomial because it is more straightforward and more it's not prone to error. It's not prone to error. So I will prefer that you learn this polynomial method. So this is how polynomial method works. So we have all our data. What are the data? We have t in minute. We have our Ca as well. We have our Ca given in mole per dm cube. So let's put all of them together. Let's check out what are they. So this is 0, time is 0, 50, 100, stuff. So is 0, 50, 100, 150, 200, 250, and 300. And the Ca is what? 0.05, 0.038, 0.0306, 0.0306, 0.25, 0.0256, 0.0256, and so on and so forth. So once we got all of that, we are going to find a polynomial fit in a software. We can use Excel, we can use MATLAB. MATLAB is more reliable in doing that. So we are going to do that now. And when we get the polynomial fit, we plot the Ca against t, against time, then it will fit. So that will be y equals to something. we are now going to differentiate d. That will be dy dx, which is the same thing as dca dt. So that is what we are going to use. So once what we differentiate is now, we stand for our dca dt. So we are going to negate that, then we find the length of that. So that is what we stand for us here. So let's see how it works here. So here I'm in MATLAB. So the t is what? Let me represent t is 0.05. That's t start from 0, 0, 50, 100, 150, 200, 250, 300. So CA, what about CA? Remember to put the square bracket. 0.05 mole per dm cube, 0.038, 0.0306, 0.0256, 0.0222, 0.0195, 0.0174. So therefore we have, those are the two parameters given, the time and the CA. So you remember from here, the time and the concentration. So we now want to plot it now. Plot in MATLAB T prime, comma CA. So that's the plot. I've seen the plot here. We can now go to basic fitting. Basic fitting. So this is the plot. We can now go to basic fitting. So when you go to the basic fitting here, yeah, you can plot it. It's going to be as polynomial. It can be fourth order, it can be fifth order, it can be anything. But fourth order, let me use the simpler one, which is fourth order. All of them will. So this is it. So this is the fourth degree. So it means what? Y equals to 3 point. So it shows y equals to 3.6, 3.697 exponential minus 12 x4, 3.697 so 3.697 exponential minus 12 x raised to power 4 minus 3.485 exponential minus 9 3.485 exponential minus 9 x cubed plus 1.343 exponential minus 6 1.343 exponential minus 6 x squared plus 0. plus 0.2978x 2978x, and finally plus 0.0499 plus 0.04999. So what do we have from here? So this y means CA, remember, that's what it means. Then our x means t, which is time. So the y, so we have to now differentiate this. What is differentiation here? The y, that is the CA dt. So differentiate this will be what? 4 times 3.697 exponent minus 12 t raised to power 3. I'm using t in front of instead of x now. Minus 3 times 3.485 exponential minus 9 t raised to power 2 plus 2 times 1.343 exponential minus 6 t plus 0.0002978 x. X will be 1. So and the constant will be 0. So that's the CADT that we need. So having gotten that, so what we are going to do is that we have our T already. We have our CA, which is already given here. So what we have to do now is that we have to put our dCA dt, put it as negative, so that we don't consume too much space. So what you have to do now, put 0 in this equation. When you put 0 in this equation, that t is equal to 0, everything will be, so that what will remain is what? This will be 0, 0, 0, then we will become 0.003 or 2978. So that means this will become, and again, this is plus, right? So it will become, the minus we are looking for will become minus 0.0002978. So when time is 50, put the 50 here. When the time is 50, put the 50 there. Put the 50 there. So put the 50 in here, 50 cube, multiply 50 square, 50 and so on. So you are going to get something like this. When you multiply it by negative, it's going to give you minus 0.00019 and so on. So and so on. So you get all of that. So let's finish this work in Excel sheet. So we have our T, we have our CA, we have our minus dCA dt. So this is 0, 50, 100, 150, 200, 250, 300. And C is what? 0.05, 0.038, 0.038, 0.0306, 0.0256, 0.0222, 0.0195, 0.0174, 0.0174. So once we get that, so what's our dCADT? So we go here in the equation we have just created. So what's our dCADT is 4 times this times t cube. So I'll just say 4 times 4 is equal to 4 times 3.79697 exponential minus 12, 3.79697, 3.697 exponential minus 12 multiplied by time cube. This is time raised to power 3. Minus 3 times 3.485 exponential minus 9 minus 3 times 3.485 3 times 3.485 exponential minus 9 times g raised to power 2 3.485 exponential minus 9 2 times 1.343 3.485 plus 2 times 1.343 times exponential minus 6 or exponential minus 6 6 times this minus 1.343, right? Okay, point is it plus 0.0002978. So now just draw everything for all of them there. It will give you what you need. So I'm trying to check that everything is still in order. So please let's remember that the last value is negative. That is minus 0.02978. So this is negative, should be minus 0.02978. So it's error here. So it's negative, it's minus here. So we need to correct that inside here. Instead of the positive that we give it here, it should be negative. And again, we have not even applied the minus here. So let's remove it. So let's find another column to create the negative. To get negative. So that means we have to multiply everything by negative in order to conform with our equation that ln minus dc dt, ln minus dc dt. So in order to create a column for that, so we multiply everything in this line, in this column, by negative 1, minus 1 times whatever is here. So what is next? If we go here, we need to take the natural logarithm of minus dc dt and natural logarithm of c and plot the two. So we can come here now, ln minus dc dt minus dca dt. So ln minus dca dt. So we need to take ln ca too, Let's take ln ca first before we take that of the so ln ca is equal to ln if you put ln is equal to ln in Excel, it will give you. So that's ln CA at 0 for all of that time. So then ln minus CA dt, minus the CA dt rather. This minus the CA dt, we take the ln as well. So the next thing is to now plot this against ln CA, so that our slope, the slope there will be alpha. So this ln CA, which should be the first one to select, and ln this ln CA, we can select only the number actually, and against this. So we plot it, put in Excel, we can put plot. So this is the plot. So to get the slope easily, we can calculate it by ourselves, but it's better to use a trend line. Add trend line, the linear trend line. So put the linear trend line. We can do it manually actually, but it may take some time. So those are it. So that means the equation is what? Y equals to 2.0415x minus 1.9477. So that means our slope is what? 2.04, and our intercept is minus. So that means our alpha is equal to 2.04, and our intercept, which is from here, what's our intercept here? Ln k prime. Ln k prime. Our intercept, which is ln k prime, is equal to minus 1.9477. So that means k prime is equal to inverse of ln inverse of 1.9477. So let's try to calculate that. And calculate that, we are going to get, take your calculator to do that, 1.9477 negative second function ln. So that will be 0.142 here. For my calculator here is 0.143. Let's say 0.143. So I think, so we have gotten our k prime and we have gotten our alpha. If you look at the textbook, the alpha in the textbook is 2.0. They approximate it to be 2.0. So which is fairly the same, 2.0. So which is second order. And the k in the textbook is approximated to be around 0.122, which is okay because of the approximation. So from there we can go and calculate. Oh, sorry, I think it's not shown clearly. So from here, y equals to 2.0415x minus 1.9477. So what we are saying is that this is the slope of the line, and this is the line has been drawn across all the points, so it's now calculating the polynomial expression for us, and this is the intercept. So what's our slope now? Is 2.041, which is second order, or approximately 2, which is second order, and our intercept, which is k prime, is equal to what? Ln k prime is equal to minus 1.9477. If you press the calculator, k prime is equal to inverse of that, will give you 0.143. So if you check the textbook is showing this as 2, which is okay, and the k prime is equal to, in the textbook, is 0.122, so which is fairly okay because of some approximation here and there. So I think by and large that's it. So the next step is to, you remember our RA is equal to KA CB naught or CB beta and CA alpha. So we have now gotten our alpha, which is 2. We have said we have represented this as k prime. So that means 0.143 is equal to K A, and we have CB. Beta is 1 because in the question we have been told that we can take it as 1. Okay. In a separate set of experiment, the reaction order with respect to methanol was found to be first order. So that means our beta is 1, and our CB naught, because we assume that it doesn't change, is taken to be 0.5. So that means CB doesn't change, it remains 0.5. So simply put, we can just say our Ka 0. times 0.5, beta is 1. So we can then find our K is what? 0.143 divided by 0.5. So divided by 0.5, 0.143 divided by 0.5. So that will be 0.286 or thereabout. So 0.286. So that is it for now. So that means our final equation is minus RA equals to 0.286 CB raised to power 1 and CA raised to power 2. So thank you. Make sure you click the subscribe button. See you in the next tutorial. Thank you.